Now we will have a discussion on three potent hormones in the athletic world: insulin, human growth hormone HGH, and erythropoietin EPO. These substances are sought by some athletes not only for their performance benefits, but also for the significant impact they can have on body composition and endurance. Each comes with its own set of physiological effects and serious risks. So let's dive into how they work and the implications for athletes who choose to use them. First, we have insulin, a key anabolic hormone naturally secreted by the pancreas in response to rises in blood glucose levels or specific amino acids such as leucine. Insulin's main function is to help cells absorb glucose and amino acids, making it a powerful agent for promoting protein synthesis in muscle. For most people, insulin levels rise naturally after eating carbohydrates, which is safe and even beneficial for suppressing muscle breakdown after workouts. However, insulin's power to stimulate growth and recovery has led some athletes, particularly bodybuilders, to misuse it by injecting it directly. This approach aims to maximize the anabolic effects of insulin, especially when combined with other hormones like growth hormone, but this practice is extremely dangerous. Improper insulin use can lead to life-threatening consequences, including severe hypoglycemia, coma, or even death. In some cases, misuse can lead to long-term insulin dependency or diabetes. So while insulin is crucial to the body's natural recovery and growth processes, injecting it without medical need is incredibly risky. Human growth hormone, or HGH, is another hormone that athletes may turn to for its powerful effects. Naturally produced by the pituitary gland, HGH stimulates muscle and bone growth, helps maintain blood glucose levels, and encourages the body to release fatty acids from fat cells, making it an appealing option for athletes aiming to alter body composition. HGH used to be incredibly rare and costly because it was sourced from human cadavers until synthetic lab-produced HGH became available in the 1980s. The introduction of synthetic HGH, created using recombinant DNA technology, made it more accessible and lowered its risks compared to cadaver-sourced HGH. Today, it's prescribed by clinicians for conditions like growth hormone deficiency in children or adults. Athletes, however, often use HGH without medical supervision to either build lean body mass or reduce body fat. HGH is also commonly stacked with anabolic steroids to amplify its effects, although scientific support for its efficacy in healthy, non-deficient individuals remains limited. Athletes may perceive HGH as a safer choice due to the difficulty in detecting it in urine tests. However, it can be identified through blood testing, a method introduced at the 2004 Olympics. Even though HGH isn't easily detected, the health risks are significant. Excessive HGH use can lead to a condition known as acromegaly, which causes bone widening, joint pain, organ enlargement, and severe metabolic issues. Abuse of HGH also increases risks of diabetes, cardiovascular issues, and other serious side effects, especially at the high doses often used by athletes. So, while HGH offers real benefits for those with a medical deficiency, using it without this need can have severe health repercussions. Lastly, we have erythropoietin, or EPO, a hormone produced in the kidneys. EPO's primary function is to stimulate the production of red blood cells, which carry oxygen throughout the body. This ability to increase oxygen delivery makes EPO a popular choice among endurance athletes who are looking to improve their aerobic performance. For example, Lance Armstrong's cycling team famously used EPO, taking advantage of the enhanced oxygen carrying capacity to delay fatigue and improve performance. The way EPO works is straightforward. More red blood cells mean more oxygen can reach the muscles, enhancing endurance. Studies show that EPO injections can increase hemoglobin levels by about 10%, improve aerobic capacity, and extend time to exhaustion by up to 70%. But this enhanced oxygen delivery doesn't come without serious risks. EPO thickens the blood, increasing viscosity. For athletes who are already pushing their cardiovascular systems to the limit, this thickened blood can lead to elevated blood pressure, blood clots, stroke, and even death. The effects of dehydration during long endurance events can further increase these risks. EPO's effects on the body are also unpredictable and difficult to control. Once injected, the body continues producing red blood cells, which can make it challenging to manage safe levels and avoid potentially deadly complications. In recent years, cases of athlete deaths in cycling and other sports have highlighted the dangers of EPO misuse. The increased red blood cell count, while beneficial for endurance, makes it a risky choice that can have fatal outcomes. Welcome to today's episode, where we'll cover two classes of substances that have made their way into the athletic world: beta-adrenergic agonists and beta blockers. While these drugs serve very different purposes medically, they found uses or misuses among athletes for unique performance effects. We'll explore how these substances work, their intended medical functions, and the potential risks involved when they're used outside of medical guidelines. Let's start with beta-adrenergic agonists, commonly known as beta agonists. These substances are chemically related to epinephrine, the body's natural adrenaline hormone produced by the adrenal glands. Epinephrine is key for our fight or flight response and plays a role in breaking down fat and increasing energy expenditure. Originally, beta agonists were developed to treat asthma and similar respiratory issues by helping open up airways and making breathing easier. But researchers discovered that some beta agonists, particularly one called clenbuterol, can also affect body composition by reducing fat and increasing lean mass. This has led athletes to use beta agonists as partitioning agents, substances that encourage the body to shift energy stores more toward muscle than fat. Clenbuterol, a popular beta agonist, is especially common among athletes who seek to increase muscle mass while shedding body fat. It's used medically as a bronchodilator to alleviate asthma symptoms, particularly in countries outside the US. Athletes, however, use clenbuterol at doses often double what is prescribed medically, following a cyclic pattern to try and maximize its effects while reducing receptor desensitization. This means they take it in intervals like 3 weeks on, 3 weeks off, with a more frequent 2-day cycling within the on weeks. While clenbuterol's potential to increase lean muscle and reduce fat sounds promising, its effects have been primarily studied in animal models and in patients with conditions like heart failure or muscle wasting. The few human studies that exist do suggest some ergogenic or performance enhancing potential, especially for strength, but we should keep in mind that we don't have a robust set of data on how safe or effective clenbuterol really is for healthy athletes. Clenbuterol is typically taken as a capsule by athletes rather than by inhalation, as it's prescribed for asthma. Users have reported side effects that include increased heart rate, elevated body temperature, tremors, dizziness, palpitations, and insomnia. Although the research on human side effects is sparse, these risks suggest a considerable downside for those using clenbuterol without medical guidance. Now, let's shift gears to another group of substances, V blockers. Unlike beta agonists, which activate adrenergic receptors, beta blockers do the opposite. They block these receptors and prevent epinephrine and norepinephrine from binding. Medically, beta blockers are prescribed to manage cardiovascular issues, including high blood pressure, by reducing the heart rate and relaxing blood vessels, but they've also found a unique role in sports that demand steady, controlled movements, such as archery or shooting. The benefits of beta blockers in sports requiring high precision come down to their ability to reduce anxiety and minimize tremors. Studies have shown that beta blockers can enhance shooting accuracy, with higher doses resulting in more significant improvements. For instance, shooters taking a higher dose of the beta blocker oxprenolol had greater accuracy than those on a lower dose. However, in some sports, a certain level of arousal or nerves might actually be beneficial. For example, in bowling, athletes with a slight increase in heart rate and adrenaline have shown better performance. So, while beta blockers might improve steadiness, they could also dampen the natural edge some athletes rely on. Despite their benefits for precision sports, beta blockers come with significant drawbacks, particularly for sports that require cardiovascular endurance. These drugs can impair exercise performance by limiting heart rate, reducing oxygen consumption, and increasing perceived effort. Studies have shown that endurance athletes using beta blockers experience slower race times and greater fatigue. The potential risks are also serious: bronchospasm, heart failure, hypoglycemia, and even issues with blood flow leading to pain or cramping.